Verify that the equation is an identity. Cosine 2x minus sine 2x, all of that in parentheses squared. We want to verify that that is equal to 1 minus sine of 4x. So since we're verifying an identity, we need to choose one side to start with and then one side as our goal. I'm going to choose to start on the left-hand side and choose the right-hand side as the goal. So here we can take this and we can square it. One thing that we want to keep in mind is that 2x is the input angle for cosine and for sine. So they're the same angle, but they do need to stay as the input and they will not change as the input for those functions. So if I'm going to write this out and I'm going to square that binomial, I need to write it out twice and then we are going to FOIL. First times the first. Since the angles are exactly the same and it's the same trig function, it's going to be cosine squared of that same angle 2x. Outer times the outer, we get negative sine of 2x times cosine of 2x. Inner times the inner, that's minus sine 2x times cosine of 2x. Last times the last, that's a positive, same trig function, so we're going to say sine squared, and it has the same angle, so sine squared of 2x. We notice that the two middle terms are like terms, so we can combine those like terms. So that would be minus 2, since there's two of them, sine of 2x times cosine of 2x, and then we're going to bring down our plus sine squared of 2x. A few things. First of all, we notice that we have cosine squared of an angle plus sine squared of that same angle. So let's go over here and remind ourselves of something. We said that if we have cosine squared of some angle plus sine squared of that same angle, what does this look like? Well, it looks like a Pythagorean identity, so this is equal to 1. So we're going to replace those two terms with 1. So we are getting closer to our goal. The rest of our goal, if we notice, it's minus sine and then 4x. So how are we going to get that input to change? We're not allowed to take the input of one function and multiply it times the input of the other function. But we can use an identity. This looks a lot like the double angle identity for sine. So let's remind ourselves what that looks like. That looks like 2 times sine of some angle times cosine of some angle. That would be equal to sine of twice that angle. So that looks like the setup that we have. We'll bring down the negative since that's not part of the identity. We have 2 times some angle, 2 times sine of some angle, times cosine of that angle. So in a previous section we discussed taking that angle and putting it inside of that double angle identity, using this as like the A. So we can put that angle inside. So what does that become? Well, that becomes 1 minus sine 2 times 2 is 4, and that's where that 4x comes from. And that is our goal. Here we have another identity that we want to verify. So we will choose one side to start with. So I'm going to choose to start with the left-hand side. And I'm going to choose the right-hand side as my goal. One of the strategies that we have discussed is taking each of the functions and rewriting in terms of sine and cosine. So that's what I'm going to do. I'm going to take tangent, write as sine over cosine, plus cotangent would be cosine over sine. And I'm going to combine these two fractions into one fraction. In order to do that, I have to have a common denominator. And that LCD would be sine x cosine x. So I'm going to multiply the top and the bottom of this by sine, the top and the bottom of this fraction by cosine. we end up with sine squared x, since they have the same angle and it's the same trig function, we can write it as sine squared x, plus cosine squared x, all over that common denominator of sine x times cosine x. We see on the top that we have a Pythagorean identity. We know that this is equal to 1. So now we have 1 divided by sine x times cosine x. Our goal looks a little strange. We notice something, that it has a double angle and it also has a 2 on the outside. Cosecant is the reciprocal for sine, so maybe we can start to approach the goal of forming a double angle identity for sine. Well, the double angle identity for sine, sine of 2x, is equal to 2 times sine x cosine x. So we don't quite have that double angle identity for sine. What can we do? We don't want to change the value of this fraction because we're trying to take something and make it look equivalent to the previous step. But for a fraction, what we're allowed to do, of course, is whatever I multiply times the bottom, as long as I multiply it times the top, then I have an equivalent fraction. So what would I want to multiply the top and the bottom by? Well, if I multiply the bottom by 2, then I have that double angle identity for sine. But in order to keep the fraction equivalent to the previous step, whatever I do to the bottom, we have to do the same thing to the top. So now we have 2 times 1 over, and all of this now matches the double angle identity for sine. So I'm going to write that as sine. Since we have this, we're going to write a sine of 2x. And of course now we have 1 over sine of 2x, and the reciprocal function, this is equivalent, and this is equivalent to 1 over sine of 2x, which is cosecant of that same angle multiplied by 2. And this is our goal.